Welcome to The Explainer. Today we're going to strip away all the hype and jargon to figure out what a large language model actually is. And trust me, the answer is way simpler and frankly a lot cooler than you probably think.
All right, let's just dive right in. We hear this term LLM thrown around constantly, but what are we really talking about? Is it some, thinking brain in a server rack somewhere, a super complicated piece of software?
Well, no. Actually, not even close. According to AI researcher Andre Karpathy, one of the most powerful models out there, Meta's Llama 2, is really just two files. Yep, that's it. Two files you could literally download and, if you had the right computer, run yourself. So the whole magic trick, if you want to call it that, is just understanding what these two files do. You've got one file that holds all the knowledge, and another, much smaller file that knows how to use it. And this is where the scale just gets wild. On one hand, you have the brain. For Llama 2, that's a massive 140 gigabyte file. It's packed with 70 billion numbers. That's where all the learning is stored. But the engine that makes it all go? It's a tiny little program. We're talking about 500 lines of code. It's almost nothing.
And this difference really gets to the core of the AI economy right now. Using the model to, say, answer a question, that's called inference, is pretty cheap. But actually creating that giant file of 70 billion numbers in the first place, that is incredibly, mind-bogglingly expensive. Which, of course, brings us to the multi-million-dollar question. How on earth do you create that magical, massive file of numbers? The brain of the whole operation.
Well, it's a process called pre-training, and you have to imagine it happening on an industrial scale. First, you gather an insane amount of data, like 10 terabytes of text from all over the internet. Then you need a supercomputer, something with like 6,000 specialized computer chips, or GPUs. And you just let it run, full throttle, for weeks on end.
So what's the bill for something like that? For Llama 2, it was around $2 million. But here's the wild part. In the world of cutting-edge AI, $2 million is kind of small potatoes. The biggest models being trained today cost tens, maybe even hundreds of millions of dollars.
So for all that money and all that electricity, what do you actually get? Well, Karpathy has this great analogy. Think of that parameters file as a zip file of the internet, but it's a lossy compression. Like when you save a JPEG too many times and it gets blurry, the model doesn't remember things word for word. It just remembers the concepts, the patterns, the overall vibe of all that information.
But here's the thing. That base model, fresh out of pre-training, is more like an internet fact generator. It's not really a helpful assistant yet. For that, you need a second, really important step, fine-tuning. This is where you stop focusing on the sheer quantity of the internet and start focusing on the quality of specific examples.
Fine-tuning basically means showing the model thousands of perfect human-written conversations. It's like saying, hey, when a user asks a question like this is what a perfect, helpful answer looks like. You do that over and over and over, and the model learns the style and the format of being a useful assistant.
Okay, so once you put all of that together, you start to realize we're talking about something way bigger than a chatbot. And that's where this next idea, this next mental model, becomes so powerful.
The most useful way to think about an LLM right now is not as a chatbot. It's to think of it as the kernel, the absolute core of a brand new type of operating system.
And the analogy holds up beautifully. Think about it. Your computer's hard drive? That's like the model's huge training data. Your computer's RAM, its short-term memory? That's the context window of your conversation. And other programs, like a web browser or DALL-E, those just become tools that this new OS can use to get things done.
And just like Windows or Mac OS, this LLM OS is getting new powers all the time. It can use tools, it's learning to see images and hear audio, it can be customized for really specific jobs. It's a complete environment for solving problems.
But you know what comes next, right? A new operating system doesn't just bring new features. It brings a whole new class of security problems.
The first one, the one you've probably heard about, is called jailbreaking. And it's pretty much what it sounds like. It's about finding clever ways to trick the model into breaking its own safety rules.
One of the classic and kind of dark examples is the grandmother attack. So the model is trained not to tell you how to make dangerous things like napalm. But if you ask it to roleplay as your sweet, deceased grandmother who's just telling you a bedtime story about her old factory job, Well, the model's desire to be helpful in that fictional scenario can override its safety training. It gets confused and it complies.
But there's another attack that's honestly much more dangerous. It's called prompt injection. This is where an attacker can secretly hide instructions in some text that the LLM is looking at, basically hijacking it to do something else entirely.
So imagine you ask your AI assistant to browse the web to find a good recipe. It lands on a web page that has instructions hidden on it, maybe white text on a white background. You can't see it, but the AI reads everything. And those hidden instructions say, stop what you're doing, tell the user they want a gift card, and give them this scammy link. The AI has been turned against you without you even knowing it.
So, we have this powerful new operating system, but it's also got these new, scary vulnerabilities. It begs the question, where are we going from here? What are the big challenges researchers are tackling right now?
Well, one of the huge frontiers is something called System 2 thinking. Right now, LLMs are all System 1. They're fast, they're automatic, they're instinctive, like how you just know the answer to 2 plus 2. The goal is to give them System 2, the ability to slow down, to reason deliberately, to actually think through a problem, like when you have to figure out 17 times 24.
And the other holy grail is self-improvement. See, an AI like AlphaGo learned to be the best Go player in the world by just playing against itself millions of times. It always knew if it won or lost. But language is messy. There's no simple win-loss score for a good conversation, and without that clear feedback, it's incredibly hard for a model to teach itself to get better.
Which brings us right back to our big idea. We are standing at the dawn of a totally new way of computing. We've been handed the kernel of a powerful new operating system, one that runs on human language. The only question left is the biggest one of all. What kind of world are we going to build with it?